The history of astronomy may be rewritten due to a new discovery, triggering a fierce debate in the astronomical community. The traditional concept of the Big Bang may just be a specific moment in the continuous evolution of this eternally existing cosmos, rather than a true beginning. This image is of an extremely distant cosmic structure, shining brightly in the early universe. The discovery of this bright celestial body has unlocked a long-standing mystery that has plagued the astronomical community. Because our current understanding of the universe is that it was born approximately 14 billion years ago. After the Big Bang, the universe underwent a period of complete darkness, known as the Dark Ages. That was a period when the universe was filled with gas clouds. Even if we built the most powerful telescope ever, we wouldn't be able to see anything before the Dark Ages. However, for decades, scientists have noticed some strange light coming from these dark layers of clouds. This serious discovery recently sparked a fierce debate in the astronomical community. The Webb telescope has for the first time observed two ancient galaxies. Interestingly, these galaxies are completely different from the galaxies we are familiar with. This has raised questions about their origin in the universe. These discoveries by the Webb telescope have raised some major questions. Is our understanding of the universe's age wrong? Or is our understanding of the origin of these galaxies wrong? So what exactly are these strange lights? And where do they come from? The new discoveries from the Webb telescope have finally solved this mystery. The conclusion is that some of our previous knowledge about the early universe may need to be revised. This new Webb telescope image shows that this light is actually a rich Lyman alpha radiation source. This indicates that in the early universe, the number of galaxy mergers was much higher than we could see before the Webb telescope began its observations. These mergers, interactions, and the massive amount of star formation they produced are the source of the Lyman alpha radiation. But scientists previously believed that this radiation should be blocked by the dense gas clouds that filled the space between galaxies during the Dark Ages. We shouldn't have been able to see this radiation, yet we did. Researchers have recently revealed that in these early galaxies, as stellar mass accumulated and stars formed, two things happened. The stars emitted Lyman alpha radiation and created bubbles and channels of ionized hydrogen in the neutral hydrogen gas that blocks light. These bubbles and channels allowed the Lyman alpha radiation to pass through. This suggests that stars can be detected from before the Dark Ages. Surprisingly, in another recent image, scientists discovered two galaxies that existed outside the early cosmic darkness. Scientists now state that these galaxies are different from the galaxies we've seen before. On the other hand, both of these galaxies are highly redshifted. Astronomers claim that if these objects are indeed galaxies, it would be a serious problem. This chart shows a comprehensive overview of the distant galaxies seen through the extraordinary capabilities of the Webb telescope. Here, we can see one of the most distant galaxies through spectral observation. Among them is a galaxy named GNZ11, approximately 13.2 billion light-years away from us. It was originally discovered by the Hubble telescope. A recent image from the Webb telescope of this galaxy has revealed something extraordinary. Astronomers have discovered a supermassive black hole at its center. This discovery makes it the most distant black hole ever recorded. It formed just 400 million years after the Big Bang, challenging our understanding of black hole formation. Due to its immense size, scientists say that the size of this supermassive black hole does not fit the cosmic timeline, because in the early universe, the death of first-generation stars or the merger of black holes could not have formed such a massive black hole. We need a completely new way of thinking to consider the formation of these supermassive black holes in the early universe. But that's not all. In this set of data, there is something else that has shocked astronomers worldwide. As we can see, these galaxies are the most distant galaxies discovered by the Webb telescope. And the red markers indicate that these galaxies have been confirmed through spectral observation. Therefore, the most distant confirmed galaxy is currently named JWST 1320, existing at a distance of approximately 13.47 billion light-years. There is more content in this data set. Here we can see the two most distant galaxies with a redshift of about 16. This means these galaxies existed before the Dark Ages. This is surprising, because our standard cosmological model suggests that galaxies first formed at the end of the Dark Ages. But here, we see large and strange galaxies existing before the Dark Ages. This discovery indicates that the time of galaxy formation is much earlier than our theoretical predictions. The question now is, how do we explain the existence of these galaxies? One possibility is that our universe may be much older than we thought. Another possibility is that something strange may have happened after the Big Bang, accelerating the formation of early galaxies. Spectroscopic observations of these two galaxies have not yet been performed. But if spectroscopic observations confirm their predictions, the foundation of redshift cosmology will be broken. There is also a hypothesis that has recently become popular among scientists: conformal cyclic cosmology. This cyclic universe model may explain the existence of these strange early galaxies. Nobel laureate Dr. Roger Penrose states that in the universe before ours, there existed a universe he called the previous eon, as predicted by Stephen Hawking. Black holes evaporated at the end of the previous eon, and the energy produced by the evaporation of these triggered the Big Bang of the next eon. He also hypothesized that the dead black holes from the previous accelerated the expansion of our early universe. Scientists believe that these dead black holes from the previous universe may explain the existence of supermassive black holes and giant galaxies in the early universe. All the discoveries made by the Webb telescope so far challenge our understanding of the universe. No wonder in just 3 years of scientific operation, the James Webb Space Telescope has already broken numerous cosmic records. including the most distant galaxy cluster, most distant black hole, most distant red supergiant, most distant gravitational lens, and most distant quasar. These discoveries indicate that our universe may be much older than originally thought, or it may be composed of a series of interconnected universes, or it may not have a clear beginning at all. Considering the infinite size of our universe, the idea of its traditional concept of the Big Bang reasonable may just be a specific moment in the continuous evolution of this eternally existing causal aggregate, rather than a true beginning. Finally, if you have finished watching this video, don't forget to leave a message in the comments section and share your thoughts on these discoveries and your views on the age of our universe. Enjoyed watching? Don't forget to comment, share your thoughts and your views on the age of our universe. No Chinese. No Chinese.